For this last segment, I'm going to take one of the examples that we've worked with before, add some data to it, and then walk through the entire process of a chi-square analysis. Of course, all the handouts that I'm about to show you are available as a packet on Blackboard, so I won't go through every single step of the math. But I will show you where all the numbers came from, and then you can, at your leisure, if you want to verify some of the math calculations and see where everything came from for yourself, if there's any questions or any ambiguities, you can do that at a later time. And of course, as always, questions, you can send questions via email or give me a call. You've seen this before. This is the 3x3 contingency table that represents something we introduced before, although I use kind of a shorthand version of the null hypothesis. The null hypothesis is discipline is not related to computer preference, and as you can see, we've got discipline as our columns, social science, earth science, humanities, those are our columns. The other variable involved in the analysis is computer use, Mac preference, PC preference, or no computer use. And we're asked to test this null hypothesis at the 0.01 level. So test whether or not, test whether discipline is related to computer preference or not. 3x3 contingency table. In this table, you can see I've added observed frequencies. This is just how the data fell. So there were, for example, 4 respondents in the social sciences who prefer Mac. There are 8 respondents in the earth sciences who prefer Mac. There are 10 respondents in the humanities who prefer Mac. There are 12 respondents in the social sciences who prefer PC, 10 responses in the earth sciences that prefer PC, 2 respondents in the humanities that prefer PC, and then 2 social scientists use no computer, or neither. 1 in the earth sciences use neither, and 6 respondents in the humanities use no computer. So those are just our observed frequencies. I've also indicated the marginals. Remember, those are called marginals, the row totals, 22, 4 plus 8 plus 10, 22. This row total is 24, 12 plus 10 plus 2 is 24. This row total is 9, 2 plus 1 plus 6 is 9. I've also added the column totals as well. 18, 4 plus 12 plus 2 is 18, 8 plus 10 plus 1 is 19, 10 plus 2 plus 6 is 18, for a total of 55. All right? So we have all I did was take the same contingency table, added observed frequencies in the marginals and the total. Again, all I did was take the 3x3 contingency table, added the observed frequencies, as well as the row totals, the column totals, also known as the marginals, and the total. As you can see, I'm preparing to calculate the expected cell frequencies for each of these 9 cells. Those expected cell frequencies can be found here. I followed the exact same formula that we followed before for each cell. Row total, 22, times column total, 18, divided by total, 55. So 22 times 18 divided by 55 equals 7.2. Likewise, for the next cell, the expected cell frequency is 7.6. 22 times 19 divided by 55 is 7.6. Same for this cell. Row total, 22, times column total, 18. 22 times 18 divided by 55 is 7.2. And I followed the same thing for each of the remaining cells. For each cell, row total times column total divided by total. So for example, for this cell right here in the lower left, row total 9 times column total 18. 9 times 18 divided by 55 is 2.946. Excuse me, that was a little close for me to see. So here I calculate and present the expected cell frequencies. So now we have a 3x3 contingency table with the observed frequencies and the expected frequencies for each cell, which means we are in a good position to calculate chi-square for each cell as well. Also, as I mentioned earlier in this clip, here is the math. That's the next page in that packet. Here's the math where I calculate each of the expected cell frequencies. As you can see, expected cell frequency, I indicate the cell here. Mac users who are social scientists, Mac users who are earth scientists, Mac users who are humanities, PC who are social scientists, PC who are earth scientists, PC who are humanities, and so on. For each of the 9 cells, this is the math that I used to calculate the expected cell frequency. And again, it's the same formula. Row total times column total divided by total total. Row total times column total divided by total total, and so on. Expected cell frequencies. So that's how this is the math as to how I calculated these expected cell frequencies. And again, once we have the expected cell frequencies, we're in a great position to calculate the chi-square value for each cell as well, which is what you will find in the next sheet. Again, the same 3x3 contingency table. I've noted the observed frequencies. I've noted the expected frequencies for each cell, except this time I've calculated the chi-square value for each cell. And the chi-square formula, as you may recall, but can also review, for each cell, I simply took the observed frequency, subtracted the expected frequency, squared it. That's a part that a lot of people miss, by the way. They forget to do that. Observed frequency minus expected frequency squared divided by expected. So observed, 4, minus expected, 7.2, squared divided by expected renders 1.422 for that cell. Likewise, observed 8 minus expected 7.6 squared divided by 7.6 is 0.021. Again, rounding to the thousandth place. Observed 10 minus expected 7.2 squared divided by 7.2. That answer is 1.089. Moving to the lower right, observed 6 minus expected 2.946. So 6 minus 2.946 square that difference, divide by 2.946 renders 3.166. I then took each of those chi-square values, each of those 9 chi-square values, and added them together for a composite total chi-square value of 14.336. So if you took all 9 of those chi-square values and added them together, you should get a number very close to, if not exactly, 14.336. That number is the amount of difference between our observed and expected frequency. That's the total amount of difference between our observed and expected frequencies. And as you learned or may recall at the beginning of all these clips, that's what chi-square represents, the total amount of difference between observed and expected frequencies. Likewise, I present you with the math sheet where you can find the math where I worked and used the chi-square formula for each of the 9 cells. Mac users who are social scientists, Mac Earth, Mac Humanities, PC Social, PC Earth, PC Humanities, None Social, None Earth, None Humanities. And again, I just simply used the chi-square formula for each cell. The observed frequency minus the expected frequency, then I squared it. Square, 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 and then divided by expected, and then the results are over here. And those are the numbers that ended up in the cell. So if you want to double check the math, you can do so there. Then I set up the probability distribution. I repeated the null hypothesis just for convenience sake. Discipline is not related to computer preference. Discipline is independent of computer preference. Test this null hypothesis at the 0.01 level. I drew the probability distribution appropriately. I indicated our critical region, 0.01. The body is 0.99. 4 degrees of freedom, 3 minus 1 times 3 minus 1, or 2 times 2, or 2 times 2 is 4. So 4 degrees of freedom, an alpha level of 0.01. This is the information I used to find the tabled chi-square value, which is 13.28. I placed that there. That's the tabled chi-square value. Then I indicated where our data-generated chi-square value should be. 14.336 would be here. 14.336 exceeded 13.28. So in other words, we observed more difference than we could expect to occur by chance alone. Therefore, we reject the null hypothesis We reject the null hypothesis of no relationship. Those two things appear to be related, meaning discipline seems to be related to computer preference. Then the last sheet in the packet is this explanation right here, where I just provide you with some language that you can use when you do your own chi-square analyses, and I'll just read it here. We observed 14.336 units of difference between observed and expected frequencies. That was our data-generated chi-square value, 14.336. Again, that's what we observed from our calculations from our data. We observed 14.336 units of difference between our observed and our expected frequencies. This amount exceeded what we could reasonably attribute to chance or sampling error alone according to the chi-square probability distribution. This number, the tabled chi-square value, that's the maximum amount of difference that we could reasonably expect to occur by chance with 4 degrees of freedom and a 0.01 alpha region. That's the maximum. We exceeded the maximum. We observed more difference than we could expect to occur by chance alone. That's why we rejected the null hypothesis. So again, we observed 14.336 units. 13.28 is what is the maximum that we could reasonably expect to occur. Therefore, we exceeded our critical chi-square value. This amount exceeded, our data-generated chi-square value exceeded what we could reasonably attribute to chance or sampling error alone according to the chi-square probability distribution. 4 degrees of freedom, a critical region of 0.01. Therefore, we reject the null hypothesis of independence. We reject the null hypothesis of no relationship and declare that discipline appears to be related to computer preference.